Hello everyone. So in this video, we are going to solve exponential inequalities. So what do you mean by exponential inequality? Okay, so it is an inequality involving exponential expressions. Okay, so let's have these properties to solve exponential inequalities. First, if b is the base, b is greater than 1, then the exponential function y is equal to b raised to x is increasing for all x. This means that b raised to x is less than b raised to y if and only if x is less than y. So if our base is greater than 1, then retain the inequality symbol. While if b is greater than 0 but less than 1, then the exponential function y is equal to b raised to x is decreasing for all x. This means that b raised to x is greater than b raised to y if and only if x is less than y. Okay, so in short, if the base is greater than 0 but less than 1, then we will going to reverse the inequality symbol. Okay, let us consider this also, the rules in solving inequalities. Number 1, if the same real number is added or subtracted from both sides of an inequality, the sense of inequality is not changed. Number 2, if both sides of an inequality are multiplied by or divided by the same positive real number, the sense of the inequality is not changed. But if both sides of an inequality are multiplied by or divided by the same negative real number, the sense of inequality is changed. Okay, take note. We are going to change the inequality symbol if we are going to multiply or divide both sides of the inequality by the same negative real number. Okay, let us try to solve these following examples. Number 1, 3 raised to x plus 1 is greater than 81. Okay, so first step, we must set our both sides of our inequality with the same base. So we will going to use 3 as the base. Okay, so that is 3 raised to x plus 1 is greater than 3 raised to 4. Okay, we can express 81 as 3 raised to 4 because 3 raised to 4 is 81. Okay, now we have the same base, so we can cancel that out. And then since that we have the base which is 3 and that is greater than 1, so we can retain our inequality symbol. Okay, so just copy the exponents. X plus 1 is greater than 4. And then solve for x. So this is x. Then we will going to move 1 to the other side. So that will become negative 1. So the value of x is greater than 3. And then for our solution set, so that is open parenthesis 3 up to the positive infinity. Okay, so we use parentheses because 3 is not included in our solution set. Okay, so this is read as from 3 up to positive infinity. Okay, number 2, 25 squared is greater than or equal to 5 raised to x plus 1. Okay, so we can express 25 as 5 raised to 2 because 5 times 5 is 25. And then multiply 2, then greater than or equal to 5 raised to x plus 1. Okay, so we have the same base which is 5, so we can cancel that out. And then since our base is greater than 1, then retain the inequality symbol. Okay, so that is 2 times 2 is 4, is greater than or equal to x plus 1. Okay, so this time we will have two solution. Okay, or we can have two process, but we can come up with the same solution. Okay, so first 4, and then move 1 to the left side, so that will become negative 1 is greater than or equal to x. Okay, so 4 minus 1 is 3. 3 is greater than or equal to x. Okay, so if we are going to read this solution, so start from the variable, so that is read as x is less than or equal to 3. Again, x is less than or equal to 3. Okay, you can write that as x is less than or equal to 3. And then for another way to solve this inequality, so 4 is greater than or equal to x plus 1. And then we will going to move x going to the left side. So from positive x, that will become negative x. And then 4 going to the right side. Okay, greater than or equal to negative 4 plus 1. Or you can have 1 minus negative 4. So they are still the same. Okay, so this time we will going to start with 1, and then 4 will become negative 1. Because 1 minus 4 is the same as negative 4 plus 1. Okay, and so for x, so negative x is greater than or equal to negative 3. And then to remove the negative sign from x, we will going to divide both sides of our inequality by negative 1. And then according to the rule that if we are going to divide or multiply both sides of our inequality by a negative number, then reverse the inequality symbol. Okay, so negative x over negative 1 is just x. Then from greater than or equal to going to less than or equal to. Negative 3 divided by negative 1 is positive 3. So as you can see, they are the same. Okay, so for our solution set, so that will be from positive 3 up to the positive infinity. Okay, so we use bracket because 3 is included in our solution set. X is equal to 3. Okay, just wait. Okay, just wait. So x is equal or less than less than. So that will be from positive 3 up to the negative infinity. Okay, or from negative infinity up to 3, up to positive 3. So 3 is included in our solution set. Okay, next, number 3, 10 raised to 5 or 10 raised to 5x plus 2 is greater than 10,000. Okay, so we can express 10,000 as 10 raised to 4. That is 10 raised to 5x plus 2 is greater than 10 raised to 4. Because 10 raised to 4 is 10,000. 10 times 10 times 10 times 10. Okay? So now we have the same base, which is 10, and 10 is greater than 1. Okay? For our base is greater than 1. Okay? So retain the inequality symbol. Okay? Copy the exponents. So we have 5x plus 2 is greater than 4. And then isolate variables from numbers. So we have 5x, or combine like terms. 5x, move 2 to the other side. So greater than 4 minus 2. Okay, 5x is greater than 4 minus 2 is 2. And then remove 5 from x by dividing both sides by 5. So this is cancelled out. So we have x here and then greater than 2 over 5. So as you can observe, we just retain our inequality symbol because we just divide both sides by a positive number. Okay, so for our solution set, that will be x is greater than 2 over 5, or from 2 over 5 up to the positive infinity. So 2 over 5 is not included in our solution set. Number 4, 1 over 10 raised to x plus 5 is greater than or equal to 1 over 100 raised to 3x. So first, we will going to set our base, or our both sides of our inequality with the same base. Okay, so this time we will going to use 1 over 10 as the base. So copy 1 over 10 raised to x plus 5 is greater than or equal to, okay, so we know that 1 is the same as 1 squared. 100 is the same as 10 squared. So that is 1 squared over 10 squared. Okay, raised to 3x. So 1 over 10 raised to x plus 5. Okay, this must be the exponent. Okay, so this must be on the upper part of our base. Okay, so x plus 5 raised to x plus 5. So be careful if you are writing the symbols or the numbers. And then is greater than or equal to. By the way, we can express this also as 1 over 10 raised to 2, since that they have the same exponent. Okay, and then raise again to another exponent, which is 3x. Now, since that we have the same base, so we can now proceed. Okay, so remember that if the base is less than 1, then reverse the inequality symbol. So 1 over 10, it will give us an answer that is less than 1. So reverse the inequality symbol. So we have x plus 5 is less than or equal to, multiply 2 times 3x is 6x, and then combine like terms. So we have 8, or we have x, and then 6x will become negative 6x is less than or equal to negative 5. So x minus 6x is negative 5x is less than or equal to negative 5. Then remove negative 5 from x, that is by dividing both sides by negative 5. So this is 1, or cancel out. So we have x, and then again, if we are going to divide both sides of our inequality by the same negative number, then reverse the inequality symbol. So now we will going to reverse again the inequality symbol from less than or equal to going to greater than or equal to. So negative 5 over 5 is positive 1. So x is greater than or equal to positive 1, or for the solution set, it will be from positive 1. Okay, so open bracket, because 1 is included in our solution set up to the positive infinity. Okay, so that is all for now about exponential inequalities. So I hope you learned from this video, and I'll see you next time. Don't forget to think positive.